Hey everybody, this is Ben and welcome back to another Leetcode video. And today we're going to be looking at problem 1663 titled The Smallest String with a Given Numeric Value. So the numeric value of a lowercase character is defined as its position, 1 indexed, in the alphabet. So the numeric value of A is 1, the numeric value of B is 2, C is 3, so on and so forth. The numeric value of a string consisting of lowercase letters is defined as the sum of its characters' numeric values. For example, the numeric value of string ABE is 1 plus 2 plus 5, which equals 8. You are given two integers, n and k. Return the lexicographically smallest string with length equal to n and numeric value equal to k. Note that string x is lexicographically smaller than string y if x comes before y in dictionary order. That is, either x is a prefix of y, or I is the first position such that xi does not equal yi. Then xi comes before yi in alphabetic order. So we just ran through the prompt. We'll talk about some pseudocode, an example, and then we'll code up a solution together. So let's go ahead and get into our pseudocode here. So we need to create the lexicographically smallest string with length equal to n and numeric value equal to k. So for example, if n equals 2 and k equals 3, two possible answers that match this criteria are as follows: A and B, and B, A. As 1 plus 2 in the first example equals 3, and 2 plus 1 in the second example equals 3. So in this case, we return AB as it is smaller than BA lexicographically. A is less than B. In our algorithm, we actually don't have to worry about doing the physical lexicographic comparisons. We'll create an algorithm that automatically returns the smallest possible lexicographic string for the given criteria. So what is the best approach in creating our result string? We need to create the string from back to front. We need to place the highest possible character, accounting for our remaining n length, at each position. Before the placement, we will decrement n by 1. So after a placement, we will subtract the index of the highest possible character from k. Now let's go ahead and get into the actual pseudocode here. So first, we'll create an alpha string that contains all of our lowercase letters in a 1-indexed order. To do this, we need to input a dummy character in our 0th index. So notice here, if I didn't have this dash, A would be our 0th index. So I need A to just equal 1 when I call it, so that's why I can put this little dummy character up front. So now if I were to call alpha character at 26, I would get Z as my return value. Then I'll create a character array of length n. I'll create an int variable of n-1, which will keep track of our index in our character array. I'll use a while loop for k, while k does not equal 0, and in each iteration we'll decrement n by 1. If k minus n is greater than 26, this means we have enough room to safely place the highest possible character at this position, which is z at index 26 in our alpha string. We can place alpha, that character at 26, at the back of our array, and we decrement our index variable after this placement. Then we subtract 26 from k. Else, we can place alpha, that character, at k minus n at the back of our array. We'll decrement our index variable after. And note here that k minus n represents the highest possible character, accounting for the remaining length of n that must be filled. We have to have n characters in our final string. So if we're placing, let's say we have 28 as our value of k, and n is our length value. So if we place 26 as z as our third character, then before that I'm going to need an a and an a, our two smallest possible characters, to fill length of 3. So just keep that in mind. And then we'll subtract k minus n from k. Actually, we'll subtract k minus n. Yeah, like that. And then we'll end our while loop. And then we'll return our character array as a string. So let's go ahead and walk through an example. So n is 3, that equals the length of the string we are to return, and k is 27, the numeric value of the string we are to return. So we create our alpha string, which was shown previously. We create a character array of size n, which is 3 in this case, and we set int t, which is going to be our index variable, to n-1, which will equal 2. So while k does not equal 0, in our first iteration, we'll decrement n at the start, so now n equals 2. Now if k minus n is greater than 26, in this case it's not, it's false, So we skip that statement. We go to our else statement. ART, which is 2, equals alpha.character at k minus n, which equals 25, which equals y. This is the highest possible character we can place at this position, assuming we must fill the next n, which are 2, positions with some sort of character. Decrement t, so now t equals 1. We'll say k equals k minus n, which equals 27 minus 27 minus 2, which equals 27 minus 25, which equals 2. Second iteration, we'll say decrement n, so now n equals 1. Is k minus n greater than 26? Nope, so we skip that, go to our else statement. ART, which is 1 now, equals alpha.character at k minus n, which in this case is 2 minus 1, which is 1. And that equals a. We decrement t, so now t equals 0, and we say k equals k minus n, which equals 2 minus 2 minus 1, which equals 2 minus 1, which equals 1. Now our third iteration, decrement n for the final time, n equals 0. If k minus n is greater than 26, that is false, so we move on. Else, we say ART, which is 0, equals alpha.character at k minus n, which equals 1 minus 0, which will equal a. Decrement t, t now equals negative 1. K equals k minus n, which equals 1 minus 1 minus 0, which equals 1 minus 1, which equals 0. So then k now equals 0. Our while loop, as you can see, will break, and we return string that value of array. Let's go ahead and code up a solution together. So first, I'm going to input string alpha instead of typing that out. Notice how we have our dummy character here just to offset our indexing so that A's index is 1 rather than 0, which is the true alphabetic order. Now I can say character array equals new character of size n. We'll say int t is going to be our index that we're using. We're starting from the back of our array. We'll say while k does not equal 0, we'll decrement n if k minus n greater than 26. We'll say ART minus minus equals alpha.character at 26. K minus equals 26. Else ART minus minus equals alpha dot character at k minus n. K minus equals k minus n. Now from here, we should just be able to return string that value of AR. And that is our full solution. We'll go ahead and run this here. So that's going to work for your test cases. Also, as you can see, my first submission, or not my first, but my last submission here, got me to 90 and 90. If I submit it again, it does run slower while I'm recording for whatever reason. So that's going to be a bit higher, but if you're doing this normally, you should get around this result, which should be 90% faster and 90% less storage than other submissions. So I hope you learned something from this problem, and thank you for watching.